Good morning. Good morning. Today I'm going through a grade 11 paper. Remember, I have covered the atmosphere. I covered the atmosphere, which is part of global air circulation, tricellular air circulation. I also covered the phone winds, the La Nina process, and desertification. I'm moving on to geomorphology now. Geomorphology. That's where I'm moving on now. Choose the term in column B that matches the description of the topography associated with the inclined strata. In column A, write only letter A to H. Next to the question number 2.1.1, 2.1.7 in the answer book. For example, 2.2.8 is I. So when it comes to inclined rock strata, the first thing that you are supposed to familiarize yourself is at some point, remember, before we moved on to look at inclined rock strata, we start off with the horizontal strata. We start off with what? With the horizontal strata. That's what we start with first before we move on to look at the inclined strata. So I think I can just give a brief of what the horizontal strata is like. Okay. Horizontal strata, we are looking at the type of strata that is more or less like this. Okay, that is more or less like this. You can see the way it's aligned. I can take this as the resistant rock, non-resistant, or a rock being the strata being made up of different layers but separated by a bedding plane. So these are layers of rock that are parallel to the Earth's surface. That's what makes them horizontal. These are layers of the Earth that are parallel to them Earth's surface, and this is what makes them horizontal strata. And these layers are separated by bedding planes. Okay, this is the bedding plane that separates this layer and this layer. So this is what this is all about. And also that this is also originate from the sediment deposited at the bottom of inland sea or flat plains over millions of years, and is then compressed into rock, and also from the volcanic eruptions that form layers from successive lava flows. This is how the horizontal actually developed. But now, we are now saying now due to forces that are within the earth, okay? So you might find that you have a situation whereby when the same strata, the same horizontal strata now, because this is where the inclined strata develop from, when the horizontal strata is tilted or dipped at an angle. So when it's dipped at an angle, of course, we are going to end up having something due to the force of compression. So this is what we mean by tilted, which means they are actually dipped at an angle with alternating hard and soft rock. This is more or less what we are talking about. So this is what makes it tilted. This is what makes it tilted. Because when you come now to the Earth's surface, it's going to come like this. It's inclined or it's tilted. That's what makes up what we call the inclined rock strata. It's not horizontal, it's inclined. So in this instance, I can take something like this. When it comes to the Earth's surface, of course, it's coming off like it's tilted. This is the way it is. Okay, it's dipped at an angle. That's what it's like. So that's basically what this is all about. So when it comes now to this, we talk about what we call the questars. We also talk about what we call the homoclinical ridge. We also talk about the Hawksback. So you need to have an understanding of what this is all about. I think just in brief, in general, before we start doing anything. So your questar is more like this. This is all right. This is your all right, and it's more like this. So this becomes your dip. Okay, these are the two things that make up our ridges. Okay, this is the scarp. This is the scarp. Okay, this is the scarp. This is the scarp. So the dip is made up of resistant rock. It's made up of resistant rock. Resistant rock. So it weathers slowly, and our scarp is made up of non-resistant or soft rock. Non-resistant rock or soft rock. So it weathers very fast. So when it comes to what we call a questar now, the tilt, we are looking at this angle here, the angle of the dip. We are looking at the angle of dip. It ranges now from 10 to 25 degrees. It ranges from 10 to 25 degrees. This is the angle of the dip that we are looking at. It ranges from 10 to 25 degrees, okay? But you can see there is a difference between our dip, which is more gentle, and our scarp, which is more steep. Our scarp, which is what? This is steep, and this is more gentle, as you can see. So those are the general characteristics of our dip slope and of our scarp slope, which makes up these ridges. So this is a question. So it means here, what do you have? You have got your dip, which is gentle, made up of resistant rock, and it weighs up slowly because the rock is hard. It takes time to erode. That's basically what we are talking about. This is more like an asymmetrical ridge with a gentle dip slope between 10 to 25, and we also have the scarp slope, which is also very steep, made up of non-resistant or soft rock. So this is your question. Then you'll see that we also have another ridge that is different in terms of the tilt of the ridge. Of course, we have got something like this as our ridge, okay, our dip. Then we have this. So this one becomes our dip. This is our scarp. So this is a homoclinical ridge. Homoclinical ridge, okay? This is our homoclinical ridge. Of course, this is our homoclinical ridge. This is still our dip. But what is different now is if you can check the angle of the dip, of course, the angle of our dip, okay? The dip slope is now between 25 to 45. It's now between 25 degrees to 45 degrees. That is the difference. The difference is in here. The difference is in here in terms of the angle of our dip, okay? There is 25 to 45 degrees, but it's still made up of the same thing. That is your dip slope and your scarp slope. Your dip slope as well is gentle. It's made up of resistant rock. It's gentle. It's made up of the resistant rock, as well as your scarp is made up of the steep slope. Then we have got what we call the Hodge-Speck, okay? When it comes now to the Hodge-Speck now, we are saying now the Hodge-Speck, we are saying now the difference now, this is still your dip. This is still your dip. This is your scarp. We still have the same thing. We still have the same thing, the scarp. We still have the same thing, the scarp and the dip. The dip being made up of resistant rock and the scarp being made up of less resistant rock. This one weighs up slowly. This one weighs up fast. But you can see now it's more or less, the dip and the scarp slope is more or less the same. But our dip slope is still made up of the resistant rock and it weighs up slowly. So basically you can see in both these different types of ridges, the Cuesta, the homoclinical, and the Hodge-Speck, all of them are made up of the dip and scarp slope. But the only difference is the angle of inclination. This one is above 45 degrees. So the angle of inclination here is 10 to 25. This one is 25 to 45. And this one is above 45. The difference in terms of our ridges is the angle of inclination. Is the angle of what? Inclination. So when it comes now, still under Cuesta, just to add, when it comes to Cuestas now, obviously a Cuesta dome, of course, it will be more like, you'll have something like this. I want to show you something more like this, okay? Okay, Cuesta dome, a dome shaped, which means more like you think about your anticline to make it easier. So when you're looking at it now, you would find that it will be more like this. So what will be, you'll have your dip here when it comes to your Cuesta dome, then which means your scarp will be what? Inside. Your scarp will be inside when you look at it now, which means your scarp will be inwards, your scarp will be inwards, and your dip will be outwards. Okay, that's basically what you're talking about, because it's sort of more like an anticline, the way it is. You can see the way it is. Then when it comes now to your Cuesta basin, your Cuesta basin is more like this now. What are you likely to have? You'll have your, okay, I'm gonna do it like this. You'll have your dip now is inside. Your dip is what? Inwards. And your scarp is outwards. Scarp is outwards. Okay. So this is the simplest way of understanding it, because this one gives you more like an like a syncline. You can see the way it's coming out here. So it will be more or less like this. That will be your how your Cuesta basin look like. This is more like your Cuesta basin, okay? Cuesta basin. So you find that the dip is inside and the scarp is outside. This is more like your This is your Questa dome. From the word dome, you can see the way it looks, basin, you can see that's how it is like. Okay, so let's go through the questions now. The first question reads, scarp slope faces inwards and deep slope outwards. So which means that is your Questa dome. That's the one. Scarp slope faces inwards. This is your scarp slope inwards. And scarp slope faces inwards. This is your scarp slope inwards. And deep slope outwards. This is your deep slope outwards, which means this is your Questa dome. Okay, which is C. So which means the answer there is what? Is C. Steep slope of a homoclinical ridge, the steep slope, which means that is our scarp. That is our scarp. Remember, I've already told you about this. Deep strata is more than 45 degrees, which means that is your Hawksbeck. The Hawksbeck, which is what? G. That is your G. Then gentle slope of a homoclinical ridge, the gentle, that's a dip. That's a dip, which is what? E. Then yields groundwater if rocks are permeable, 2.1.5. That is your Questa basin. It yields water when the rocks are permeable. Remember your Questa basin, the way it is, of course, that is your F. Describes asymmetrical ridges, 2.1.6. Describes asymmetrical ridges, that will be your homoclinical ridge, which is H. Then dipping strata lies at an angle of 10 to 25 degrees. That will be your Questa, which is B. So these are the answers for these different types of inclined stratas. These are the answers. I think I've explained. I've also given more information in as far as the Questas, the Questa dome, the Questa basin, the Hawksbeck, the homoclinical ridge is concerned. Let's move on to the next one. Refer to the 2.2 below, which shows different types of mass movement. Make the descriptions below with the kinds of mass movement in this sketch. Choose the correct answer and write only the kind of mass movement next to the question numbers in the answer book. If, for example, 2.1.9, soil creep, you may choose the same kind of mass movement more than once. So the next thing that we are now talking about is the mass movement. We need to understand what it is. The first thing is we need to understand what it is, because we cannot just move on to give the answer before we understand what mass movement is all about. So mass movement involves the downslope movement of weathered material under the influence or the force of gravity. The movement of weathered material down a slope under the influence of gravity, the movement of weathered material down a slope under the influence of gravity. So when we talk about the rockfall, I'll try to just add a few things so that at least you have an idea. Rockfall, this is the fastest form of mass movement, which involves the free fall or downslope rolling of rock pieces loosened by weathering. We are saying now, when you look at it now here, some of the rock has been loosened by weathering. Like let's say, for example, they've been let's say the type of physical weathering, like exfoliation. Let me just talk about exfoliation, just to be simple. Okay, so it happens that the rocks expands and contracts. At some points, the rock starts to peel off and it falls down a slope. That's more or less an example of a rock fall. Its weathering has actually taken place. It can also be to maybe some form of chemical weathering. Of course, maybe the rock has been exposed. The reaction between like your hydrolysis, what does it? Hydrowaterlysis, which means water action, can also result in the weakening of the rocks, assuming that the area is in an area that is humid, of course, which means the rocks can end up also falling down the slope. So it's exposed to weathering in general. We are not being specific to say it's only physical or chemical weathering, but it is weathering, which is the breaking down of rocks into smaller pieces. So these rocks are now falling due to the force of gravity. That's part of your rock fall. The fastest form of mass movement that involves the free fall or downward rolling of rock pieces loosened by weathering. Okay. Okay, let me end there. I don't want to add a lot of information. Then also, when you talk about now the landslide, we are saying this is a form of mass movement. This is a form of mass movement that travels downslope more rapidly than mud flow. It forms that there. It travels downslope rapidly more than mud flow. It is the collapse of the slope. You can see it is the slope is collapsing. the collapse of the slope, and does not need water as an agent. It does not need water as an agent. The slope just collapse, you can see, then it moves down slope. Okay, then when we talk about mud flow, we are talking a form of mass movement in which a section of the soil or weathered material lying on rather steep slope becomes saturated by heavy rains or begin to move downwards. It becomes saturated by heavy rains and it begins to move downwards. Okay, it is a rapid movement. It's common in arid areas, especially after a heavy rainfall. So these are the different forms that we have. We also have the soil creep, which is the smallest form of mass movement. Which involves the slow motion of soil layer down, indicated by the slight downhill tilt of trees and other stationary objects. It occurs under dry conditions where there is less vegetation. That's where it occurs. We can see under, it occurs under dry conditions where there's less vegetation. Soil grains expands and contracts due to difference in temperature, and this causes them to move. So we are saying now this also slope is exposed to higher and low temperatures. So this is what actually causes the soil particles to expand and contract, which means at the end of the day, it causes them to move down slope. So these are the different types of mass movement that we have. These are the 4 different types of mass movement that we have. Let's go through the question now. Rapid flows of mixtures of rock and soil down the slope. So the first one is rapid. Remember, we talked about mud flow, of course, occurring dry area just after heavy rains. So the rapid mixture of rock and soil and water, which means that is our mud flow. That is our mud flow. Then the second one is curved tree trunks and tilted fences are the effects. Can you see here? Can you see here? Curved tree plants, of course, that is your soil creep. That is your soil creep. Then most rapid kind of mass movement, obviously we are talking about our rock fall. We are talking about that is number 2.2.3. That is our rock fall, which is this one. Then common in arid and semi-arid areas, that is our mud flow. Remember, usually after heavy rain, that's when it happens. Okay, that is our mud flow. Earthquakes can trigger this type of mass movement. 2.2.5, that is your landslide. Then slowest kind of mass movement, 2.2.6, that is your soil creep. Then a combination of slumps and debris flow, 2.2.7, that will be more like your landslide. Then originates on steep cliff surfaces, that is your rock fall. So boys and girls, this makes up our 1.1 and 1.2, which are short questions. We have looked at this one that looked at inclined strata, and we have also looked at 2.2 that also looks at the type of mass movement. Thank you.